Welcome to Chapter 10, Section 5, Angle Relationships in Circles. The essential question is, when a chord intersects a tangent line or another chord, what relationships exist among the angles and the arcs formed? What you will learn is how to find angle and arc measures and use circumscribed angles. Our first theorem is the tangent and intersected chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So what this is talking about, so we have a couple of segments here that are intersecting segments and lines. So this line right here, let's call it A, it's the only point on there. So line A is a tangent line because it only touches the circle at one point. And this inside here, segment AB, is a chord. Touches the circle twice, and it remains inside of the circle. So this is what the first part of the statement says. So tangent and chord intersect. So then what this is saying is that the measure of each of our angles that is created, so for example, this angle 1, that is going to be equivalent to 1/2 of the intercepted arc, so 1/2 of arc AB. And then angle 2 is going to be equal to 1/2 of arc ACB, or BCA. So that is what this theorem is talking about. So then let's go over here to our first problem, how to find either an angle measure or an arc measure. Okay, so it says line M is tangent to the circle, and we see that the chord within the circle is intersecting at that tangent, so we can use that theorem that we just learned about to find the measure of the angle. All right, so as we said that if that happens, this angle here is half the measure of the arc that it intercepts. Okay, so then this is going to be half of 130. And then this is going to give us 65 degrees. Okay, so the measure of angle 1 is 65 degrees. Now for this one here, the second one, we actually have the measure of the angle. The measure of the angle is 125. I have to find the measure of the arc. And since the angle is half the measure of the arc, then I can work backwards and say, well, if the angle is half of the arc, then I work backwards by multiplying it by 2. So the measure of the arc is actually 250 degrees. And that is how you find the measure of an angle or an arc measure when we have a tangent intercepting a chord. All right, we have a couple theorems to go before we go to the next example. So angles inside of the circle theorem. If two chords intersect inside of the circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. All right, so for example, if we want to find the measure of angle 1, we're going to find the measure of angle 1 by adding its arc and the arc of its vertical angle. So we want to add this measure plus this measure and then cut that in half. To find the measure of angle 2, we're going to add the arc across from it and then the arc across from its vertical angle, and then multiply that by 1/2 or divide it by 2. Okay, so that is when we have two angles angles that are created inside of a circle using two chords or lines. And then we have angles that are created outside of the circle. So if we have an angle outside of the circle, for example, here, if a tangent and a secant, or two tangents or two secants intersect outside of the circle, then the measure of the angle that is formed, so angle 1, angle 2, angle 3, can be found by 1/2 the difference of the measure of its intercepting arcs. Okay, so to find the measure of these angles, so angle 1, angle 2, angle 3, we basically do the same thing. So we multiply by 1/2 to the difference. So we're gonna subtract our larger arc, boom, boom. Take that measure, we're gonna subtract it from this arc here. Okay, so the two arcs that are created by the interception of the secant, the tangent, will be create an angle outside of the circle, which is found by subtracting the two arcs created and multiplying it by 1/2. Okay, so we're about to try those two out. So we're gonna start with when we have angles that are intercepting inside of the circle. All right, so we said that if we're looking for an angle inside of a circle, we're going to add. So inside means add. Okay, inside we're going to add that arc and the arc across from its vertical angle. So we're going to add those two. So that x is equal to 1/2 of 130 plus 156. So I'm adding both of the measures of the arc, and then I'm going to divide it by 2. So then x is equal to 1/2 of 286. Okay, so 1/2 of 286 is equal to 143. So that is the measure of this angle x. All right, and then to find an angle outside of a circle, so then we're looking for this angle. Okay, so then x is going to be equal to 1/2, right? That's what it said. We got to still multiply by 1/2. And then we're going to be, instead of adding, we're going to be subtracting. So we're going to take 178 minus 76. We're going to simplify what's in the parentheses and then divide it by 2. So 178 minus 176 is 102. If you divide that by 2, you're going to get 51. So x is equal to 51. Okay, so if the angles intercept inside, you are adding. If your angles intercept outside, your lines intersect outside and create an angle outside, you are subtracting. And for both of these, you multiply by 1/2 or divide by 2. Next theorem. If we have a theorem, circumscribed angle theorem. A circumscribed angle is an angle whose sides are tangents to a circle. All right, so circumscribed angle. This is only a special type of angle when we have two tangent lines that create an angle. So it can only work with two tangent lines. Okay, so when we create an angle using two tangent lines, we have a circumscribed angle. So basically the circle is within the two tangent lines. So what we get is the measure of a circumscribed angle. So this angle here, ADB, is equal to 180 degrees. Okay, so keep that number in mind. Minus angle ACB. So angle ACB. So let's make that a different color. ACB. All right. So to find this angle, I am going to do 180 minus whatever the measure of this angle is right here. All right, so let's try that on this problem here. So what we're going to do, the first one's going to be pretty easy. So we're going to do x is equal to 180 minus the measure of this angle here. So that's going to be 135. So if we subtract that, x is equal to 45. Right? And that's because the circle is circumscribed by the tangent lines. It's a circumscribed angle. Now this one here, the second one's going to be a little bit more tricky because we don't have that central angle, right? And it has to be in measure minus the measure of the central angle. But here we don't have a central angle. Central angle would be located from GF to E. So that right there. So we would be looking for this angle. But we can find the measure of this arc and that angle by using this value of x. Okay, so I know that this central angle is going to be twice as much. I mean, if you add 180 to it, you'll get the angle that you desire, right? Because this angle, 30, is equal to 180 minus this angle EGF. I'm just going to call this a different variable, say just y. Why? Just because that's what I want to use. Okay, so I'm basically working backwards to figure out the measure of that angle. So then this is going to be using inverse operations. We're going to subtract 180. It's going to give me negative 150 is equal to negative y. If I divide by negative, you're going to get 150. So this angle, this angle y, I'm just going to change it now. That angle right there, the black one that we drew, just going to make it in black, is 150 degrees. Right? Which means that the arc... Okay, so we're basically combining multiple parts of what we've already learned. So that means that this is also 150. So now we can find x. So we're doing multiple steps to figure out x, right? Because x is a circle, is an angle that is not at the center. So this is an inscribed circle. Okay, so if we remember, we know that an inscribed circle is equal to half the measure of the arc that it contains, so half of 150. So then x is going to be equal half of 150, which is 75. All right, so for this one, we combined multiple parts to find missing parts of an angle so that we can then use that to apply to the angle that we're missing. So notice here how it's gonna, if you just try to get like a shortcut or something, it's pretty hard to get from 30 straight to 75. There's no like way that you can do that without going through these extra steps to find the missing parts. All right, so in this lesson, you should have learned what happens when a tangent line intersects a chord. How do we figure out an angle that's inside the circle and outside the circle, and then what circumscribed angles are and how to find them. If you have any questions, please feel free to leave a comment or question in the comment section down below. And we'll see you next time.